Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 149, determine the angle alpha which locates the principal axis of inertia through point O for the rectangular area. Also specify the maximum and minimum moment of inertia of area. So here is the given figure. We have a rectangle with dimension b, height 2b, and x prime axis or the u-axis is from the figure, it is counterclockwise from the x-axis. But based on experience, the axis of inertia where the principal axis where moment of inertia of the area is maximum should be somewhere here. So let us verify if my suspicion is true. So for the solution, let's compute Ix, which is moment of inertia of rectangle with respect to the x-axis or the base, b height cube over 3. B height is 2b. So Ix is b times 2b quantity cube over 3, and that is 8 thirds b to the fourth. Iy on the other hand is b cubed times 2b over 3. So Iy is b cubed times quantity 2b over 3, and that is 2 thirds b to the fourth. Then product of inertia with respect to the centroid is 0 because it is symmetric with respect to both axes, plus area of rectangle which is b times 2b, barred x is b over 2, barred y is b. So p sub xy is equal to 0 plus b times 2b, b over 2 times b. So it is b to the fourth. So product of inertia equals b to the fourth. We then substitute into the formula tangent of 2 theta p, or in general tangent of 2 theta, equals negative pxy over quantity ix minus iy over 2, where p means principal axis, or you just call it 2 theta. And in this case, it is supposedly 2 times theta, which is the value of alpha. So negative b to the fourth tangent to theta p equals negative b to the fourth over quantity 8 thirds b to the fourth minus 2 thirds b to the fourth over 2. Since 8 thirds minus 2 thirds is 6 thirds or 2, divide by 2, so 1, so that is negative b to the fourth over b to the fourth, so that's negative 1. So inverse tangent of negative 1 is negative 45 degrees. So tangent of 2 theta p is negative 45 degrees. So negative means clockwise from the x-axis. So it's really clockwise. The x prime axis should be here so that it will coincide with the principal axis. So theta p or alpha therefore is half of 45 degrees. So theta p is alpha equals negative 22.5 degrees. Then for the maximum moment of inertia and minimum moment of inertia, it is equal to 1/2 of quantity ix plus iy, then plus minus square root of quantity ix minus iy all over 2 square plus product of inertia sub xy square. So Imax or minimum equals 1/2 quantity Ix plus Iy, then plus minus square root of quantity Ix minus Iy over 2 square plus P sub xy square. So everything is known. Substitute Imax or minimum is 1/2 of quantity 8 thirds B to the fourth plus 2 thirds B to the fourth plus minus square root of quantity 8 thirds B to the fourth minus 2 thirds b to the fourth, which is 2b to the fourth divided by 2, so that's b to the fourth square plus b to the fourth quantity square. Therefore, it is the radical is b to the fourth square root of 2. While this one is 5 thirds b to the fourth plus minus b to the fourth square root of 2. So the maximum moment of inertia is 5/3 b to the fourth plus square root of 2b to the fourth. And in decimal, it is equal to 3.081 b to the fourth. While the minimum moment of inertia is 5/3 b to the fourth minus square root of 2b to the fourth. And that is 0.2525 b to the fourth. So that's it for this problem, and I hope you can recall the formula after I derive it in the preceding slide. Level 150, determine the moment of inertia about an axis through O and the angle alpha to this axis for the triangular area shown. Also specify the maximum and minimum moment of inertia of area. So here is the given figure for our solution. Let's solve for Ix. Ix is, for the triangle, is bh cubed over 12. So it is equal to 4 times 8 cubed over 12. And that is equal to 170.67 inches to the fourth. Iy, on the other hand, is, in this case, 4 cubed times 8 over 12. So Iy is equal to 42.67 inches to the fourth. While the product of inertia x sub y is b square h square over 24. If you cannot recall, you review the past videos under moment of inertia and you can find there the derivation. So pxy equals b square h square over 24. So 4 square times 8 square over 24. And that is equal to product of inertia xy is 42.67 inches to the fourth. Then tangent of 2 theta p is equal to negative p sub xy all over quantity ix minus iy all over 2. So substitute. Tangent of 2 theta p is negative 42.67 all over quantity 170.67 minus 42.67 over 2. So from there, we can now compute 2 theta p with your calculator. It is equal to negative 33.69 degrees. So therefore, theta p, which is alpha in the designation form shown, is equal to negative 16.845 degrees. For the maximum and minimum moment of inertia, Imax or Imin is equal to 1/2 quantity Ix plus Iy, then plus minus square root of quantity Ix minus Iy over 2 square plus product of inertia with respect to xy axis square. So everything is known. Imax or I minimum equals 1/2 of quantity 170.67 plus 42.67 plus minus, or for this case plus square root of quantity 170.67 minus 42.67 over 2 quantity square plus 42.67 square. So Imax is equal to 106.67 plus 76.92, while I minimum is 106.67 minus 76.92. So Imax is equal to 183.6 inches to the fourth. Then the minimum is, you just use minus here. Level 151, compute the principal centroidal moments of inertia for the plane area. Here is the plane area. It consists of a quarter circle, 8 inches in radius, and a rectangle, 8 inches base, 6 inches height, but below the x-axis. So for our solution, let's compute Ix, which is for the quarter circle, pi radius to the fourth over 16. The area, by the way, is pi over 4 8 square plus 8 times 6 for the rectangle to locate barred x and barred y, to locate the centroid. So area is equal to 16 pi plus 48. Then by Varignon's theorem, quantity 16 pi plus 48 barred x equals 16 pi times 4r over 3 pi, of 4 times 8 over 3 pi plus 48 times barred x is 4 inches, half of 8. So computing barred X, it is 3.691 inches. Then quantity 16 pi plus 48 barred Y equals 16 pi times 4 times 8 over 3 pi also. Then plus 48 times negative 3. The centroid of the rectangle is negative 3 inches below the x-axis. So barred Y is equal to positive 0.2714. Then moment of inertia with respect to the x-axis is moment of inertia of quarter circle plus moment of inertia of rectangle with respect to the base. So that is Ix equals pi 8 to the 4th over 16 plus 8 times 6 cube over 3 for the rectangle, 8 cube over 3, because the x-axis is also the base of the rectangle. So it is equal to 1380.25 inches to the 4th. Iy is pi 8 to the 4th over 16 plus 8 cube times 6 over 3. And it is equal to 1828.25 inches to the 4th. Product of inertia xy for the quarter circle is r to the 4th over 8, while for the rectangle, with respect to the centroid 0 plus area 48, barred x is 4, positive 4, barred y is negative 3. So pxy is equal to 8 to the 4th over 8 plus 0 plus 48 times 4 times negative 3 for the rectangle. So product of inertia sub xy equals negative 64 inches to the 4th. Then we use transfer formula. Ix equals I barred x plus area barred y square. So 1380.25 equals I barred x plus area quantity 16 pi plus 48.2714 square barred y square. So I barred x can now be computed. It is equal to 1373 inches to the 4th. And Iy 1828.25 equals I barred y plus area 16 pi plus 48 barred x squared 3.691 square. So I barred y is equal to 489.53 inches to the 4th. While pxy negative 64 equals p barred xy plus area quantity 16 pi plus 48 barred x is 3.691, barred y is 0.2714. So computing for p barred xy, it is equal to negative 162.44 inches to the 4th. Then for Imax minimum, it is equal to 1/2 of quantity Ix I barred max or minimum 1/2 quantity I barred x plus I barred y plus minus square root of quantity I barred x minus I barred y over 2 square plus p barred xy square. Product of inertia with respect to centroid square. So substitute I barred max or minimum is equal to 1/2 quantity 1373 plus 489.53 plus minus square root of quantity 1373 minus 489.53 over 2 square plus 162.44 square. So I max or minimum, I barred max minimum equals 931.265 plus minus 470.655. So for the maximum, use plus, for minimum, minus. So I barred max is equal to 1,402 inches to the 4th, while I barred minimum is equal to 460.6 inches to the 4th. So that's it for this problem.